Everyone, welcome back. In this particular video, we will be discussing the problem. Find the two numbers in array which are non-repeating. What is given is an array in which all the numbers except 2 are repeated once. Means there are two k plus 2 numbers where k numbers are occurring twice. All the numbers are occurring two number of times, but two elements are there who are only occurring once. So out of all the array elements, two elements will be distinct, rest all will be repeating. What we need to do is find those numbers which are non-repeating, which are unique, which are distinct in the most effective way, most efficient way, and return those in a sorted manner. We have to return them in increasing order. So if I take the example, having array of 8 size, the elements in the array are 2, 3, 7, 9, 11, 2, 3, 11. So as you can see, array is not sorted. Given this array, what are the two elements which are non-repeating? 11 I can say is repeating, 9 is non-repeating, so 9 is one of the answer. Then 7 is also non-repeating, so 7 is the other answer. And since 7 is smaller than 9, 7 will be first, 9 will be second. Rest, as you can see, 2 is also repeating, 3 is also repeating. So only two numbers will be there which are non-repeating, which are distinct, and all the others are repeating. The point is how we can figure out those two numbers which are non-repeating. So for that, what we are going to do is I'm going to write some of the numbers. Let's take a little bit different test case. What I am doing is I am taking a number which is, let's say, 1011. I am taking a number, although it is not 1011 in the form of integer. In integer, you can say it will be 4, 5, actually 8, 9, 10, 11. This will be 11. Then let's take one more number which is maybe 1000, which is nothing but 8. I'm just taking few numbers. I'm also taking one more occurrence of 8. This is the second occurrence of 8. Then let's take few more numbers. Let's also take 7. This is nothing but 7. And let's also take one more occurrence of 7. Let's take a value which is maybe 6. So if I take 6, it will be 1, 0, 1, 0. This will be 6. And let's also take some value which is repeating. So I am taking one more value, maybe the other value which I am taking is nothing but 5. So 5 I am taking two times. The value is 1, 0, 0, 1, 1, 0, 0, 1. So these are the array values present. Obviously, array is having 11, 8, 5, 8, 7, 6, 7, 5. So as I can see in this entire array, there is a value 6 which is unique, and there is a value 5 which is unique. Rest 8 is repeating, 5 actually is repeating also. 5 is not unique, 6 is at least unique, and 11 is unique. 5 is repeating, 8 is repeating, 7 is repeating. So our answer should be 11 and 6, although in increasing order, that is 6, 11, not 11, 6. But the point is how we can figure out those numbers. One of the brute force solution can be just check for each number whether it is repeating or not. First check for 11 whether it is repeating again or not. No. So 11 is one of the answer. Check for 8. Is it repeating? Yes. So it is not the answer. Is 5 repeating? Yes, it is not the answer. Is 8 repeating? Yes, it is not the answer. Is 7 repeating? Yes, it is not the answer because it is repeating. 6, is it the answer? Yes, because it is not repeating. So just return 6, 11. So what will be the brute force approach? It will be just a nested loop approach where we are first having the loop to find out whether 11 is repeating, 8 is repeating, 5 is repeating, and so on. Check each index whether it is repeating or not. And in order to check it, we need another loop, a nested loop, an inner loop. So overall time complexity will be n square. That is quadratic time complexity because n into n, the worst case will be n square. And space we will not require as such. There will be a constant, it will be actually constant space solution. But the point is, can we do better than this? And the answer is yes. If you know that in the sorted order, all the duplicates will become consecutive, then actually you can use that consecutive behavior to find out whether an element is repeating or not. That is, how about once we are sorting all the elements, that is 5, then 6, actually there are 2 5s, then 6, then there will be 2 times 7, then there will be 2 times 8, then there will be 11. So in this array, I can say that if a value is repeating, it will be the next occurrence also. So 5, is it occurring again? Yes. So it is not the answer. 6, is it occurring again? No. So it is the answer. 7, is it occurring again? Yes, so it is not the answer. 8, is it occurring again? Yes, it is not the answer. 11, is it occurring again? There is no occurrence after 11, so it is the answer. So we have found both the answers. So once sort the array and check what is the next occurrence. If it is not same, then that element itself will be the answer. And obviously you have to just skip by two indices every time. So what I will do is I will run a loop in order to uh, check whether each element is repeating or not by checking with the next index. But before that, we need sorting. And since we need sorting, the overall time complexity will be n log n, because sorting in the most optimized manner will take n log n in time, due to heap sort or quick sort or merge sort, these kind of inbuilt sorting algorithms. And as such, there will be no extra space. We can just do the sorting in the same array. But the point is, can we do even better than this? And answer is still yes, we can do better than this. We can have a trade-off. That is, if we want to reduce the time complexity, we can take some extra space to even further reduce the time complexity. That is, I will just store all these numbers in a hash map kind of data structure, where I will store the frequency of each number. What I will say is, how many times 5 is occurring? 2 times. So in the hash map, 5, 2 will be there. How many times 6 is occurring? 1 time. How many times 7 is occurring? 2 times. How many times 8 is occurring? 2 times. How many times 11 is occurring? 1 time. Now just check in the hash map what all keys are having value 1. That is, they are present only 1 times. So to build this hash map, to fill this hash map, it will take linear time. And to check what is the 2 keys which are non-repeating, it will again take linear. So linear plus linear will be, of course, linear. So hash map will take linear time only, but on what cost? On the cost of space complexity. You will take extra space of linear data structure, which is hash map itself. You have to, in worst case, push all the nodes from the array. Obviously, there will be only n by 2 nodes roughly, but still it will be linear in worst case time complexity or space complexity. So this is the brute force, this is the sorting technique, this is the hash map solution. But is it the most optimized solution? My answer is no. There is one more solution which is actually based on bit manipulation. But that solution, I must tell that it is not an intuitive solution. You can't directly figure out that particular solution. It will be a little bit trickier to figure out. But I will write the time complexity first. What will be the approach time complexity? It will be linear only, because obviously if we are optimizing, we should at least have the same time complexity or even better than that, that is lesser than that. But it will be linear only. What we will actually optimize when we are discussing the bit manipulation solution is, we will not take this extra space. We will have the bit manipulation solution to take just constant space solution. It will not take any extra auxiliary data structure. What is the solution? I deliberately wrote all the binary representation of all the array numbers which we have. First step. What is the first step which we will get? The first step will be to do the XOR of all the numbers. Now, why we are doing XOR? I'm just first telling what we have to do, and then I will tell why we are doing it. Because I already told this solution is not an intuitive solution. You can't figure out the most optimal solution on your own. So first you have to do the XOR of all numbers. What is the XOR's property? This is a very important property of XOR. Any numbered, if it is XORed with 0, it will remain same. A XOR 0 will be A only. Any number, if it is XORed with itself, it will be 0. Any number, if it is XORed with 0, that is 0 XOR A, it will be A only. 0 XOR A equal to A XOR 0 equal to A. But if two numbers same are being XORed with each other, they will become 0. These two properties are heavily used in this first step. That is, first do all the numbers XOR. So if you will do the XOR of all the numbers, 11 XOR 8 XOR 5 XOR 8 XOR 7 XOR 6 XOR 7 XOR 5, what this will give you? Let's say this is the answer. This is the variable I am saying, which is XOR itself. The variable name is XOR. So this number will come out to be, if I will say 8 and 8, 8 XOR 8 will give you 0. So it will just like get removed. Then you can say 5 XOR 5 will be 0. So remove it also, because zeros or anything is always that same thing. Zeros or anything is that same thing. So you can just discard the duplicates. 7 XOR 7 will also be 0. Only remaining number will be 11 and 6. And of course, 11 XOR 6 will be some other number. If I will just first of all figure out what is that number, just represent 11 in the binary. So it is 1011 in binary. XORed with 6 in binary. 6 is nothing but 1010 in binary. What it will come out to be? 1 XOR 1 will be 0. Same bits XORed, they will give you basically 0 value. If same bits are XORed, they will give you 0 value. If different bits are XORed, they will give you 1 value. This is also a property of XOR. So 1 XORed with 1, giving you 0. 0 XORed with 0, giving you 0. 1 XORed with 1, giving you 0. And finally, 1 XORed with 0 will give you 1. So this is what you will get, which is nothing but equivalent to 1. This number is nothing but 1 only. So once you have XORed the all numbers, what you are actually getting is just the two numbers which you want as the answer. However, they are not separate. They are just in a single number represented as the two numbers which we want XORed between them. That is 11 or 6, which we are having as 1. So from 1 or from this XORed number, we actually have to figure out both the numbers. That is the number 11 also and the number 6 also. But how to figure out both 11 and 6? We should have some mechanism. Now, what is the second step? It is also very tricky step also, I must say, and non-intuitive step, but easy after you are able to at least go through the video. So the second step is, once you know this number, which is 0001, what you have to do is you have to check any of the bits which is set in this number, which in this case is the 0th bit itself, 0th index bit. Check what all numbers are having this particular bit as a set in all of the input in the array numbers. That is, in what all numbers is this current bit set? Due to that only you can say the bit will be coming out to be 1. So just take a XOR of only those values where this particular bit is set. So what I will do is in the second step, only do XOR. This is, let's say, XOR 1. Only do XOR of those numbers where this particular bit is set. Do XOR of only those numbers where one of the bit is set from the answer, from the XOR 1, where we can say the rightmost bit is set, where the RSB, rightmost set bit, is set. So what we will do is we will do XOR now for 11 because it is having this bit set. We can check easily whether a bit is set or not by doing a mask. I am not discussing how to check whether a bit is set or not right now. That you can actually take as a prerequisite, that you should already know how to check whether a bit is set, how to set a bit, and all of those operations, basic bit manipulation operations. Anyways, the XOR 2 will come out to be 11 because its bit is set. Since 8's 0th index bit is not set, don't do XOR with 8. Since 5's 0th index bit is set, do the XOR with 5. Since 8's 0th index bit is not set, do not do XOR with it. Since 7th 0th bit is set, do the XOR with it. Since 6th number is not having the 0th bit set, don't do XOR. 7 is having 0 bit set, do the XOR. 5 is having 0 bit set, do the XOR. Now what you will get is, actually this is 5, not 7. You will get this number, and as again, if you will apply the property, 5 XOR 5 will give you 0. 7 XOR 7 will give you 0. Only the number remaining is 11. And I must tell you that this is one of the numbers which is unique. And if you know one of the numbers which is unique, if you know the two numbers XOR is giving you 1, out of which you already know the first of the number, you can find out the other number by using one more property of XOR. What is that one more property? If A XOR B is a C, it also means A XOR C will be B. You will use this property to find out the second number. If 11 XOR 6 is equals to 1, and if you know 11, you can figure out 6 by doing what? 11 XOR 1. So if one of the numbers, this is the first number, is 11, the second number, although not in the sorted order, but the second number will come out to be 11 XOR 1. That is XOR 2 XORed with XOR 1. So if you will do the XOR of these two numbers, it will give you 11 XOR 1. That is 1011, 1011 XOR with 0001. What it will come out to be? 1 XOR 0, 1, 0 XOR 0, 0, 1 XOR 0, 1, 1 XOR 1, 0. So 1010, which is nothing but 6 only. So you are able to get the other number. So first, do the XOR of all the numbers. What it will give you is the two numbers in a XORed form, which you need to figure out. Out of these two numbers, you can figure out any of these numbers by taking one of the bit which is set in this number, most probably the rightmost set bit, because it is very easy to figure out the rightmost set bit. It is just a operation which is known as the n and with minus n, where n is the number in which you have to figure out the rightmost set bit. So just figure out the rightmost set bit in this number by using inbuilt function. Most probably there will be an inbuilt function also, or you can use n and minus n operation to figure out rightmost set bit. After you are figuring out this rightmost set bit, just check in what all numbers is this rightmost set bit set, and only to the XOR second time only for those numbers. What will happen is one of the numbers which was unique will not have the bit set. One of the numbers which was unique was having that bit set. Then only the output will come one here. What does one mean? The different bits XOR will give you one. And if different bits XOR will give you one, obviously one of the number will have one of the number will have zero. That is doing the XOR of only those numbers where the bit will be set. It will give you only one number out of the two numbers which are unique. And if you know one of the numbers out of two numbers, you can easily figure out the other number also very easily just by doing XOR of this with this. That is, do the XOR of these two numbers. So it is a lot of XOR operations being used. These are actually the majorly three XOR operations or three XOR properties. Not only these, but also the basic properties that the same bits, if you are doing XOR, 0 XOR 0 is equal to 1 XOR 1 is equal to 0. And 1 XOR 0 is equal to 0 XOR 1 is equal to 1. So these are the four properties or five properties, whatever, which you are using. So that is the approach. And as we are just doing XOR operations, which are constant operations, overall time complexity will be linear plus linear, which is linear without extra space. So let's now write the instruction manual for this particular approach. So first step, what we need, step number 1 is do the XOR of all numbers of array and store it in XOR 1. Then find out the rightmost set bit in this XOR 1 number. So let's say it is stored in and store it in RSV. Store it in a variable which is known as RSV. Now, second step will be just do XOR of only those numbers where RSV is set. Where RSV is set. RSV is having one value. It is one bit. And store it in XOR2. And maybe you can say and store it in XOR2. So once you have both the numbers XOR1 and XOR2, you can say one of the numbers will be XOR2 itself, other number will be the XOR of these two numbers. So let's say, so answer will be, you can say the minimum of XOR2 comma XOR1 XORed with the other number, that is XOR2. And the other number will be the maximum. So answer will be array, of course. Answer is array containing first the minimum of these two numbers and maximum of these two numbers. Same, that is XOR2 and the XOR1 XOR with XOR2. That is, one of the numbers will be 11 itself and other numbers will be 11 or 6, which is 11 or 1, which is 6. And you have to first print minimum one, that is 6, and then you have to print the bigger one, which is 11. So you will return that answer array. So return the answer array. You just need to do what? You just need to maintain a function or make a function to check whether RSV is set or not. So you also have to make a function which will do what? Which will return a Boolean variable, or you can say a true false value. Check set bit, which will do what? Which will take a number and check whether a corresponding bit is a set or not. And how to check a bit is set or not, that you should know, or you can again use an inbuilt function. But I'm just telling you that first you have to create a mask. I'm not discussing how to check a set bit right now because already the problem is very long. Create a mask with value one left shift bit. Once you have created the mask, you have to find out if the value n and with the mask, is it going to give you a non-zero value or not? If it is going to be giving you non-zero value, then bit is a set, return true. Otherwise, bit is not set, return false. This is how you check whether a bit is set or not. We will be writing the code for the problem. Find two numbers in array which are non-repeating. Do the XOR of all the numbers. And in order to do it, I am making a first number which is XOR1, initially starting from 0 and doing the XOR of all the numbers present in array. So I will run a loop over all the elements and I will just say simply that XOR1 will be XOR1 XORed with the current element. So this is how you can do the XOR of all the numbers. Now figure out the rightmost set bit in this particular number, which you can do in Java using integer dot lowest one bit function. There is an inbuilt function. However, I've already told you that if you want to figure out the lowest set bit, the rightmost set bit, using a operator, what you can do is you can do XOR1 XORed with the minus of XOR1. This will give you the rightmost set bit without using any inbuilt function. You can try to figure out some of these values, although this is a well-known formula, so I'm not going into that thing. So what we can do is we can say the rightmost set bit will be integer dot lowest one bit. This is the inbuilt function in Java, and I will input the XOR1 number. Now what we have to do is do the XOR of only those numbers where this particular bit is set. So actually what you can do is you can again run a loop, again set another number starting from 0, run a loop over all the elements of the array, but now only do the XOR of those numbers where, let me first write the XOR thing, but only those numbers should be XORed where this corresponding bit is set. So we can actually, instead of using the check set bit function, we can actually directly just do the AND of these two numbers and check whether the value is 0 or not, because it is not going to give you the bit index. It is directly give you that mask value. So you can directly do the AND with mask. So what we will do is we will say whether the element and the mask, that is rightmost set bit, is it non-zero. If it is non-zero, then only do the XOR, otherwise don't do the XOR. That is what we have mentioned here. So only do the XOR if the bit is set, the rightmost set bit is set. Now one of the numbers will be XOR2, but other number will be XOR1 XORed with XOR2 and return in the form of minimum comma maximum. So I will say return a array, return a new array containing first number as the math dot minimum of XOR2 comma XOR1 XORed with XOR2. However, the other number will be the maximum, that is a greater value number. So we will say XOR2 or XOR1 versus XORed with XOR2. So first give the minimum number, then give the maximum number, or the first give the smaller number, then give the greater number, because we need an increasing order. And let me just write it in two different lines. So it is also running right now. So it is working as expected for the sample test case. Let me just add few more spaces and let's just submit it for the checking of whether it is working for all the test cases or not. So this is actually just, you can say, two-step approach. First step is to find the XOR of all numbers. Next step is only to find XOR of those numbers where the rightmost set bit is set. So it will only give you one of these numbers which are unique. And other number which you can get is by doing the XOR1 XORed with XOR2. So all the test cases are correct, as you can see. And this is the code working in linear time complexity. Linear plus linear. Linear plus linear is linear. And these operations are constant operations. So overall time will be linear and space will be constant because we are not taking any extra data structure as such. So linear time, constant space solution for the problem, find two numbers in array which are non-repeating in most optimized fashion. With that, we are done with the problem. We will meet in a new video with a new problem. Till then, bye-bye. Take care.